The presentation is titled PostgreSQL for Oracle People, Abridged. Originally, the version was much longer than what I have today, like for more than an hour of talking. But since the whole contents was based on, or thought as a kind of introduction for Postgres and Postgres features for people who usually work with Oracle and do not have very much experience with Postgres. So the biggest part of the presentation submitted like presentation of features, since we are actually having someone with a practical experience of migrating big system. Max will be talking next to me. And I think that we can safely just let this go, especially that so many presentations tackles the problem already. So what I have today for you is an approach to the Postgres as such, as from a rather quite different perspective, more historical, more theoretical one. I think it might be interesting because me personally, I haven't met many presentations or talks that are approaching this issue of comparing Postgres and Oracle from this very perspective. So PostgreSQL for Oracle People Abridged. I think that it is good to start the presentation with a nice quotation. This is Fifth Rule of Programming by Rob Pike. I usually, at every job I had, I used to have this printed out on rather big font and having it with me at my desk. I've got inspired by my friend who is working in IBM, and in their office they have the moose, plush moose. And when something very, very ridiculous happens or is being heard, they are just passing over the moose. Someone is having this moose on his desk and just banging the head with the desk, but with the moose inside as a way to just cushion the impact. For me, I'm not that very much focused on cushioning the impact, but time and again, I've been seeing situations when people are just forgetting about this, and I'm having this on my desk. And when, for example, I'm overhearing some senior programmer explaining to some junior programmer how to use databases, many times I used to just bang my head on this very quotation. Just let us have this sing in, because I think that this is something that is many times not taken seriously enough. And I think it's just a brilliant way to remember how important are data to us. And since we are here talking about Postgres and about Oracle, I think that this is something that is close to each and every one of us. How this talk originated originally. I had not much practical experience with actually administering PostgreSQL. To gain that and to exploit what I already know, I joined Cybertec this January, but I've had this situation where I had to explain things about Postgres because quite surprisingly to me, being so much involved into this, it is not widely available or known knowledge. So I would have a few situations that I will share with you when it was quite hilarious, when I was trying to start to talk with Postgres with my superiors, with managers, with people who should know. And that was the origin. I just wanted to have the single place when I can just have something ready at hand to present to someone who wants to know or who should know. How are we going to go through this? So a few slides for introduction. Then we will focus on lineage of the Postgres and Oracle and how they were developed, how the features were developing over time. Then we'll have a short architectural comparison. It might be not very much in depth, but I think that I will be able to cover key elements. Then we will omit the Postgres feature review, which is the most part of this presentation. And then I will just glance over a few theoretical aspects of porting that will, I hope, get the more practical development in Max talk. So just to introduce me, then we will talk about a few facts about Oracle. Well, I know that perhaps most of you, if you are attending this, have some practical knowledge of Oracle, but this is just to set the stage and get a few key facts to compare to PostgreSQL. Then we will talk about Postgres, and then just a glance at community, which is essential, it's central to Postgres. Who am I? I've been a system analyst for more than a decade, actually closer to 20 years right now. A few years ago, I've been quite accidentally made an architect. I'm not very sure if this is the right thing, but anyway, I've been doing architecture, being an analyst for a long time. I've been working mostly in telecom and banking sector, and for some years right now, I've been self-sponsoring to attend the PostgreSQL Conf EU, so the European gathering. And last visit to PostgreSQL Conf EU 2019 in Milan proved to be quite, I shall say, fruitful, because as a direct result of some nice talk with alcohol and without alcohol, since January, I've joined Cybertec, who decided to open a company here in Poland. Usually, before that, I've been known as this guy with a funny diagram to shout at, thinking that this diagram can explain something to someone, and usually, quite surprisingly, to those who were opposing initially, it happened to be so. As for my practical and business-related involvement with Postgres, it was mostly a side tool, not endorsed by the companies I've been working with, or for, so quite unofficial, but helped me immensely at few gigs I already have to solve the problems that were not really mine, but were essential to the success of the projects I've been involved with. As a disclaimer, many years ago, I've been an admin of Oracle in the 8i era. So it was a few years ago. It was a huge application that is still till this date managing students' records at Silesian University of Technology in Gliwice. How to contact me? In virtual realm, I'm non-existent, so no Facebook, no Twitter, no nothing. But you can send me an email. Now to the Oracle. This is by no means a comprehensive summary, but just to set a few things. So it has been started a few months before 1977, originally written in assembler, then published as a Digital Equipment Corporation focused database system, as already version 2. It is being developed in a very closed manner, closed source. One company is responsible for this. Licensing is obviously commercial, absolutely no open source there, rather strictly enforced, many modes of licensing, and there are for some time a version that are available free of charge, albeit quite limited in licensing terms. Support is usually single sourced, paid quite dearly, based on subscription. If you want to have patches for Oracle, you have to pay Oracle. And what platforms it runs on? Obviously, since version 18C, it is mostly cloud, to the point that the initial release was cloud only. Only after a few months, it has been made available in on-premise versions. So now we have obviously Linux, Windows, AIX on Power 64-bit, Solaris as a dying but still maintained and viable platform directly from Oracle, HPUX on AI64, but this is actually still kept alive as a result of a very expensive lawsuit, and ZOS on System Z. It used to be much more than that, because at some time Oracle was available on 35 OS and hardware platform combinations. It was around version, I would think, version 6. But since then, as the commercial Unix branches and alternative systems were slowly dying out, this has come to the number we are presenting right now. Now, how it compares to Postgres. It was initially released in 1987 as Postgres without SQL. It was the original query language was PostgreSQL. In something that resembles what we know now, it has been since 1995. Then there was the trend to name everything by date. So you remember Windows 95. There was also Postgres 95. That was quickly renamed as PostgreSQL. I think that one of the core team members, Bruce Momjan and others, in a very famous mailing list, called the worst decision in the project history. Because frankly speaking, no one is able to remember how to pronounce this. And still, even in Poland, I often hear that people are just calling it Postgre without SQL. It is being developed in a free and open source manner, and the authority is global team, core team. It is quite unique because really what is, I think it's one of the strongest advantages. It is just no single company that controls this. So we are not like, for example, MySQL, and we are not going to face a situation that Monty Videnius, who was the MySQL AD founder, faced some time ago, that just to retain some control after selling to Oracle, to Sun and then to Oracle, he had to fork and start an independent company. There is no single company. Due to the very, very liberal licensing, we have many forks because everyone can fork. These are happening, these are appearing, disappearing, dying out. Some are being strictly closed source, some are being open sourced after some time. Strictly commercial licensing is available. My company also is able to provide a commercially licensed fork, which is repackaging, because, for example, some customers may want to have something that's boxed. As for support, it's multi-sourced. We can have basically as many models as you want. Community is obviously very strong, but if you want or have to have contract, you can buy a contract, you can have an incident or subscription-based contract to support yourself, or you can just ask for support one time. No problem. There are plenty of companies that are going to provide you with this kind of services. Now, for the platforms, what we have, Postgres was originally based on Unix, so this is the most prevalent fork, but we have other platforms supported, mostly Windows, which is mostly important, and at some time it was available only as a build on platform on Cygwin. Now it is for some time available as a native build. Not as performant as Postgres on Unix-based platforms, but still. And obviously, we do have a quite strong support in the cloud in the form of platforms offered by specialized vendors, like, for example, Heroku, or as a platform offered by very biggest cloud providers like, for example, Amazon with the RDS Postgres, which is pretty close to standard. So you can comfortably use it. As I've said, very, very important part of Postgres is its community. This is not the most recent photo, but I think that the nicest one I've encountered. Perhaps as I do not have a strong exposure to social media, something is missing. But here we have the photo from 2017, I think, in Ottawa. So the community is the strongest and most important part. We have 3 tiers of development contributors. It's the global core team. And as for now, I've checked just yesterday, it's still Peter Oysonot, Margus Hagarde, Tom Lane, Bruce Momjan, and Dave Page. We have 30 people who have been designed as major contributors, and 32 people who are contributors. All all of this is available on Postgres site. So if you want to see those people and their corporate affiliations or none, you can check there. Generally, what is quite unique in Postgres is that the development is based both on corporate contributions and individual contributions. And what is really quite amazing to me is that there are situations where companies decide to pursue some particular feature. They may initially start to develop this feature as a closed source part as their competitive advantage, then decide to open that. But at times it happens that they do not see commercial viability or commercial advantage in that. But then such features may migrate between companies. And we do have situations when something was orphaned by one company and taken over by another, or just one company not being able to devote as much resources as they used to, may ask for help, and other companies may join to contribute to that. Now let us go to the Lineage part of the RDBMS and those two databases we are talking today about. So I will be talking about two particular people who are quite seminal to the development of both projects. Then we will have a quick look at the genealogy of the relational database systems in like high overview. Thankfully, there is a research project going on still in Germany that publishes the family tree, updated like every 2 years, which will bring quite a nice overview, high-level overview. Then we will go through the development of Oracle features and comparison when and why, and perhaps why not Postgres gained something comparable. Then we'll take a look at Postgres timeline and so. So sometimes it is that there are very important people for a project, like for example, Linus Torvalds for Linux project. Postgres does not have Linus Torvalds. As I've said before, we have the core team, but there are people who are important both for Oracle and for PostgreSQL respectively. And those people are CEO, well, as for now, ex-CEO and still chairman Larry Ellison for Oracle Corporation, and Professor Michael Stonebraker, who is currently Professor Emeritus at MIT, but recently joined Enterprise DBA as a scientific advisor. But his role and his original vision is something that I will attribute the success of PostgreSQL and viability of PostgreSQL after almost 30 years of development right now. So let's look at Larry Ellison. Those two people, Larry and Michael, are roughly the same age. They've been involved in many business endeavors during their professional careers, but except than that, they're quite different. So Larry is 76 right now. He established Oracle in 77 and is quite known for being very relentless person as to the motive force behind Oracle commercial success. The means he's using to achieve this success are not always commendable. And as far as I know, I do not have any direct information about he being personally involved in developing Oracle kernel or Oracle code. I decided to take some distinguishing feature for both of those people. And for Larry, I would say it is his net worth. As you can see, despite some wobbling during the dot-com bubble crisis, he is currently, I think, 10th or 8th on the Forbes most affluent people in the world, business people in the world. I don't know how his academic record shapes up. I think he has been a dropout from the academia, but I don't know if, at least I wasn't able to find anything about his scientific publications. Now for Professor Stonebraker. He is still 76 right now, was born a year before Larry, but we are in the time of the year when they are the same age. In a way, he is a foundational person in the general computer science related to database technology, mostly as much as COD and his seminal publication. His role and his diversity has been recognized in 2014. He has been made laureate on the American computing, I don't know how this, ACM Turing Award. It's the closest thing to Nobel Prize in IT you can get. I would highly recommend materials from this time when he was rather thoroughly interviewed by as a living history project with Turing Award. There is almost 4 hours, 3.5 hour interview with him, which is immensely interesting. Quite bad audio quality, but I recommend this. And also his lecture as a Turing laureate. His endeavors in developing database technology was very, very many. Usually he was following the cycle of first starting a project in academia as a scientific project, and then trying to commercialize it. While commercializing and trying to profit from it financially, he was almost ready to start again in academia with some new idea. And how it shapes up, you can see. First was obviously the Ingress, which was the one of the first relational database in existence in 1973, which was then commercialized at RTI. Then there was a Postgres project, meaning no PostgreSQL. There was no SQL at that time. It was still PostgreSQL based, which was then commercialized as Illustra. Illustra was sent to Informix, and for many years Stonebraker was Informix CTO. But then he started with another. Mariposa investigated federated databases. Aurora investigated streaming databases. CStore investigated columnar storage, quite a new thing at that time. Morpheus was focused on metadatabase and data integration. HStore, again, addressing storage of very, very high throughput data streams into the distributed database. SciDB, special scientific research, also with federation. And his most recent Tamer is purely commercial project, focused again on data integration. I think that it is just a recognition that the data integration in current enterprise is a very important problem. And most recently, Michael Stonebraker made a full circle, joining Enterprise DB as a scientific advisor in 2019. So the record is pretty impressive. And his original design and ideas that were incorporated in Postgres project, which was purely scientific, as something that's going to break out of the mold made by Ingress project, post-Ingress. This was the origin of the name. We are still benefiting from this vision 30 years later. So now the map, the genealogy tree of the databases. We have these small indicators, red for Ellison, blue for Stonebraker, and how it works. This is the most recent I was able to get genealogy of the database systems. I don't know how readable it is on your screens, but it is quite extensive and covers everything from the biggest systems, the earliest systems, to something that is completely desktop oriented, like FileMaker or Microsoft Access. And Larry Ellison started Oracle, yes, but take a look how Stonebraker impact is distributed on this map. So we have the Berkeley Ingress. Then by forks, we are seeing that this is something that's mostly associated with Postgres lineage, but also things that were long-lived, short-lived. He's all over the place. And this is absolutely a tribute to his seminal role in database technology. How this all started? Obviously, we need to start with Edgar Codd, who created while being an employee at IBM in 1970, a publication called A Relational Model of Database for Large Sharp Data Banks. It was a transformational piece of work that suggested that database can act as something that is being just told what to provide and not how to provide it, and the relational structures can be embedded into the data model. So this was something that was really transformative, but initially it wasn't recognized as such, partly because IBM was focused on well-established products. You know, IBM being a huge corporation, it was quite involved into the internal competition between different products, and the product at that time, IMS, was very strong, a huge cash cow for big customers of IBM, and IBM wasn't very much interested into changing paradigm. If something works for them financially, then why to do something different than that? And it was quite interesting because then we've got basically two ways of developing. This seminal paper was seminal in two ways. First was IBM System R, which was initially developed within IBM, and you see the difference between those two products. Originated almost at the same year, 1974, but otherwise they were quite different on every level. IBM made it from commercial reasons, quite half-hearted approach. The other one was Ingress, funded by Stonebraker, but in academia with funding from US military, from National Science Foundation, and from the university. The languages were different. The commercialization for the first and the second came at different time. Target platforms were completely different, very diversified. IBM, it was obviously mainframe. Ingress was targeting something much smaller, and the way it was distributed was quite important. IBM was obviously providing this as commercial product, but never shared the source. Ingress, on the other hand, being a research project, was commercialized, but sources were shared in academia, to the point that even in socialist Germany, there was a product based on Ingress called DBA, developed by Robotron and Technical University Dresden. Both projects were quite seminal because the System R resulted in the SQL DS data store, and then System 38 that evolved into the SQL 400 and the DB2 for iSeries. Then we have the DB2 for MVS, which is currently still sold as DB2 for ZOS. And then the general DB2 Universal Database, which later was targeting Linux, Unix, and Windows. And those three branches are still being commercially available. They are still somewhat separate, and they are still being sold and developed. This is very broad, but the appearance of those two systems set the stage for development. Then let's go through the history of Postgres, how timeline was shaping up. I have this small map on the bottom, and let's just go through the foundation. Then Stonebraker took the Ingress and commercialized it. And while it was commercialized, the last release was in 1984. Oracle was at version 4 at that time. Then to break the mold, a Postgres project was established, 85, 86. It is important to know that there was no code transfer. So how we can see on the map, there is a mark indicating there was a fork. It wasn't. It was starting from clean sheet. And then it was ended at some time, and the code was took over by people from the community. 3 postgraduate students of Stonebraker. They decided to take the code because they've seen a potential in that. And the very first decision was just to abandon Quell, which as a language is, I think, still available in Ingress commercial releases sold to this date, and replace the interpreter with SQL, which is becoming quickly an industry standard. And then it just go on. Version 6 of Postgres, which was the first more or less viable release, was at Oracle version 8. Version 7, which established it well, was Oracle version 8i at 2000. And then it goes, at version 10, we had a change in numbering scheme. And we have the version 12, which is current, released October 20. Oh, there is a mistake, 2019. Now, how the features of the Oracle were developing and what Postgres was doing to get on par with those features. First release was based on the features of IBM System R, and it was quite funny because IBM was quite open with the development, perhaps not seeing a very strong threat to their other offerings like IMS, and they were publishing papers. And Larry Ellison was audacious enough to call the people from IBM laboratories to ask them about specific features developing Oracle internally at the same time. So the situation was so peculiar that IBM was publishing papers about what is going to happen in System R development, while Larry Ellison was just coding this and made it commercially available before IBM. It wasn't very portable, it wasn't very feature complete, but nevertheless, IBM was lagging behind Oracle, and Oracle was implementing results of IBM research faster than IBM itself. First release that was viable and feature complete was in 1979. Postgres was much later because the code base was picked up in 1994 and then released in 1995. First usable version in 1996. First release of Oracle was in assembly for VAX. Then in 1983, it was written in C, somewhat portable, but not standard compliant to be run everywhere. And this decision, how to develop it and what platform to target, still impacts even till this day Oracle. There is lots and lots of legacy code still available, and it's huge code base, not perhaps the most easy to maintain. Postgres, on the other hand, was developed in C from the very first day because it was targeting Unix systems, so it was the standard for that time. Version 4 gained transactions. Again, there was a version 4 gained transactions in 1984, somewhat more standard compliant and aiming at more universal portability. Postgres was transactional from the very beginning, but full multi-version concurrency was available in version 6.5 in 1995, and we get to the true serializable isolation in 2011 in version 9.1. Version 5 in Oracle brought us the client-server architecture. Originally, it wasn't client-server. All clients were running locally on the same machine, communicating with database through shared memory. It also brought us subqueries and embedded SQL. Again, Postgres was client-server from the very beginning. Embedded SQL was introduced in version 6.3 in 1998. Version 6 brought concurrency improvements with row-level locks, online backups, and shard pool in 1988. For Oracle, Postgres again, online backups was from the very beginning, shared locks from the version of 8.1. It was a big release because it really improved somewhat lagging performance of this academic project in Postgres for a very long time, known as something not perhaps quite feature complete, but not very performant, at least compared to his biggest competitor in the open source. Quite late in version 7, Oracle gained data integrity. Logic in the database in form PL/SQL migrated from Oracle Forms and Reports that was living outside of the database. Improvements to the optimizer. These feature, respectively, constraints and triggers appeared in version 6.2 in 1997. First version of logic in database in 1998, but it wasn't the most common now PL/PG/SQL. It was PL/PG/TCL. And the optimization in genetic optimization in version 6.1, probably because it was quite academic, so it was a natural way to get this. Oracle also at version 7 gained native Windows support for Postgres much later. This was the big feature of version 8 in 2005. Partitioning, advanced indexing in version 8, 1997. Partitioning in Postgres is available in perhaps not the most perfect form, but getting there from version 10. Materialized views from version 9.3, quite a mature thing right now. Then it was version 8i in 1998. It was the version I've touched Oracle for the first time. That was quite difficult to tame, I would say. The great internet.com that was raising there, so Internet, Java, and the Linux port. For Postgres, Linux was also obviously the natural thing from the very, very beginning. PL Java is not part of the core product, but you can run JVM in Postgres instance since 2005. And it is available and can be used, albeit the implementation of logic inside database in Postgres is quite different to Oracle. We will talk about it in the future. Then the shared disk clustering XML flashback query in version 9i in 2001. Postgres does not have shared disk and probably will never have. XML is available since 8.3 from 2008. Recently, version 12 has hugely improved and standard compliant Postgres processing. Flashback query, being a form of temporal query, is not available at all in Postgres, so you cannot have this as-off mechanism. Then version 10G with self-management and self-tuning, Postgres isn't there yet. We can have statistic updated and optimizer is taking care of this, but a certain amount of hand tuning is still required. Now the most recent features, like from last 15 years, real application clusters, automated storage management in 2006. Those features are not really relevant in Postgres since the certain areas are addressed very differently. In 2009, compression, consolidation, online upgrades. In Postgres, storage data is compressed natively in the blocks on disk, but online upgrades are possible, but not in core product. We are not there yet. Cloud, multi-tenancy, and improved temporal features in Oracle version 12c. Cloud offerings are available, but certainly since we are not such an all-encompassing corporation as Oracle, we do not have them natively. There are specialized vendors like Heroku who are offering this for customers. And the rest actually is not quite there, since the most modern features, the being by Oracle singled out as the most important features, do not have such an application to Oracle, so no comparison there. Okay, so let's go quickly through the architecture. let's see how certain things are being called in Oracle and Postgres, then some high-level overview of Postgres and Oracle instance, some similarities, some differences. So an Oracle instance is what in Postgres is usually called a cluster. Instance is being called, named as something that is a set of processes attached to some memory pool and using a set of disk persistent objects. In Postgres, it's called cluster. In Oracle, instance. Data storage unit for Oracle is a data file. Postgres stores data very differently. For every object is at least one file, and it's stored as a normal file without any tuning on disk. In Postgres, in Oracle we have database, but in Postgres we have a database, and this is actually lower than the cluster, because in Oracle one instance equals one database. In Postgres there can be many. They are pretty isolated, with exception of few shared elements, like for example user. Data storage location is called table space. In Postgres, we also have table spaces, but they are implemented quite differently. Basically, it's just another directory. In Postgres and Oracle, we have schemas, but in Postgres, they are not tied to a role. So schema is just an independent object and can be owned by, one user can own many. It's just like a namespace. The way both system tackles recovery, so recovery data is in redo log in Oracle, the same write-ahead log in Postgres. Transaction rollback is called in separate segment in rollback segments in Oracle. Postgres doesn't have it due to the difference of how the multi-version concurrency is implemented. Transaction log is archive log in Oracle, and the write-ahead log archived is the same thing in Postgres. Database status, obviously, the control file in Oracle, we have PG control in Postgres. Data on disk are stored in segments. Segments in Oracle can have different sizes. In Postgres, the segment is equivalent to page, and page is always 8 kilo. The code in database in Oracle is obviously as a packaged and stored procedures and functions. We do not have packages in Postgres. We have functions and quite recently procedures. The interactive monitor, what you use every day, is SQL Plus in Oracle and PGSQL PSQL in Postgres. Actually, the tool to go, because it is so nice, and especially if someone was forced to use SQL Plus in Oracle and not any overlay on that, he will very much appreciate how PSQL is convenient. In Oracle, we have the privileges and grouped in roles. In Postgres, we also have roles, but they are like an amalgamation of the username and role in Oracle sense. So that's just a security identifier that has rights assigned to this. And basically, user is the role that can log into database and can be granted to one another. And how the mechanism is being designed to communicate with the external world. For Oracle, it's the listener process. For Postgres, it's the postmaster. The thing is that in Postgres, the postmaster is just the hard link to the PostgreSQL binary, and it attaches to the network sockets, listen, and spawns the processes for maintaining the instance. So there are no separate binaries for that. Okay.
Michał, just wanted to say that it's like
4
minutes left. So if you could, that would be wonderful.
So I think with that, I will left the last part, the migration, since Max is going to talk about it anyway. Then we can just go back to this, and perhaps it's an indication that there will be a place for another talk to just continue with this.
Perfect.
So we have the instance, we have some network, we have some client and server, and the instance is the running database within some server. We have some additional programs for that communicates with the instance, either locally or through net. And we have those three components, like the storage, the memory, and the processes. The storage has some files, some control files, some persistence and rollback elements. There are some processes that are maintaining the database operation. We have some shared part because those processes are communicating with one another usually through shared memory. And then we have some processes that are communicating with clients. They can be threads in the threaded server. They can be separate processes in the context of the process-based server, and they are communicating through this shared memory. How it shows in Oracle. This is very simplified. I've seen much more complicated diagrams, but they will be completely unreadable here. And we're talking about dedicated server mode. So we have an Oracle instance, some utility programs like imp, like exp, like SQL Loader, SQL Plus, and other programs communicating with the instance through the network, through the Oracle net, or locally through shared memory. Then we have some storage. We have some processes and memory. In storage, we have some data files. We have a control file, redo, and archive log, and the configuration files. We have dedicated set of processes that are responsible for maintaining the process, the instance. So there is a DB writers, log writers, archivers, checkpointers, listeners. Then we have this shared memory called SGA, Shared Global Area, which is quite extensive in Oracle. It's different than Postgres, different organized. Then we have the server processes that are spawned by listener on incoming connection. We have OK.
Tu vois? Je vais les mettre dans le garage, tu veux? Dans le garage?
We have the dedicated area for the processes, and this is how mostly this instance is organized. Now, comparative to that Postgres, we have obviously Postgres cluster running on a server, some utility programs, some programs using the libpq network interface, or locally, like pSQL and PGCTL, but the mechanism of communication is the same. You don't have something like Beak within Oracle. Everything goes either to socket over the network or locally. We have some data files which live in the designated area called PG data, set of processes, and the memory. In the PG data, we do not have huge files like in Oracle with data files Oracle. They are just collected as a set of files within designated directories. We have some control files. We have the archive log in the form of write-ahead log. We have configuration. We have the processes that are maintaining the instance, responsible for synchronization, for replication, for archiving, for vacuuming, for collecting statistics, and so on. And shared memory that is a bit more limited than in Oracle. And then on incoming connection, Postmaster spawns Postgres processes. We do not have threads in Postgres. Every connection gets its own process. And they have the dedicated memory just for their use. And there's one very, very significant difference. Oracle, due to historic reasons, uses disk files as directly as possible. Postgres doesn't. So for caching and for efficiency, operating system cache, dependent totally on the open operating system implementation, is vital. And every call to the disk goes through this operating system cache. No direct access. So both databases are quite similar in their features, but there's nothing like the similarity was quite superficial. So a few areas. For Oracle, it is usually that the Oracle as a corporation used to be all for everyone. So one-stop shop. Postgres, on the other hand, is just a layer. So to get this completeness of solution, you need to use tools and elements that are external to Oracle. Postgres project won't provide you an application server. There are companies that are trying to follow Oracle, offering Postgres. Usually Enterprise DB is singled out like that. But nevertheless, the Enterprise DB, being a commercial Postgres vendor, they do not have anything comparable to Oracle offering, especially after all those acquisitions of Oracle. Then how to treat the operating system. What I've said, for Oracle, originating in a very, very diversified set of platforms, Oracle was trying to replace as much as possible. So even to the point that the row partitions were available. Postgres, on the other hand, embrace, but not extinguishes as many features of the operating system as possible, to the point that caching, for example, is PostgreSQL job. This difference in approach is something that stems directly from the early days of Oracle, when the database kernel must supplant operating systems to be portable. For Oracle, for Postgres being mostly originating in Unix, certain sets of features was always taken as granted. Now the attitude to engineering. I don't know if it is not a bit too harsh to Oracle, but Oracle was always trying to be business correct, while Postgres, with its scientific or origins in academia, till this day is trying to be engineering correct in the first place. That goes to the point that sometimes if we are doing something in a way that is still not in SQL standard, and then SQL standard redefines this, like for example, the mechanism to query JSON in database, then Postgres project just re-implements it in a way that standard dictates. Oracle was quite different in that. They're usually strong-arming. Due to their huge size and presence, they were able to dictate the way the things in standard are shaping up. And for example, the way the JSON is being queried in database is based on Oracle implementation. But that strong arming approach is changing. They are becoming much more standard compliant than they used to be.
Michał, could we do like the last minute, please?
Yes,
like,
last minute.
Yeah,
and we are going to end with that. Obviously, the development, Postgres strives to be as open as possible, Postgres, Oracle as closed as possible. And the last thing I would like to notice is the way that the logic is implemented. In Postgres, the logic in database, so functions, triggers, procedures, are very, very simplistic. So the database engine doesn't have much of a knowledge what's going on. On Oracle, on the other hand, the language is implemented as the very, very integral part of the database. So in Postgres, we have like 12.5 languages in the database, but they are not quite able to integrate with the database kernel so closely as Oracle. It's important to remember about this. Okay, so I think that since I already used my allowance, we are going to stop here, and I'm passing over to Max.
Yeah, thank